Good afternoon, Manav. I'm Ronak, DSCE, and joining me are Aslan, Haider, and Tanveer, and we are gonna put forward a presentation on renewable body aircrafts. And let's start. So these are the topics we are gonna cover in the presentation, and I will be covering the first 4 units. The next 3 units will be covered by Aslan. Haider will be discussing about the design and structure of BWP aircrafts, and concluding will be Tanveer with the examples of BWP aircrafts. So, classification of aircraft in general. There are four kinds of aircrafts that are in picture in real life. The first one is the conventional configuration, that is tube and wing. That is all the commercial planes that fly in. They are basically the conventional. They have the conventional configuration where the fuselage and the wings are not blended and are separate. So the next kind of aircraft are blended wing body aircraft that we're going to discuss in detail. In these kinds of aircraft, the fuselage and the wings, they are blended smoothly, and to give there is no partition between the fuselage and wings. And hybrid flying wing aircrafts is a combination of the first two aforementioned aircrafts, and then we have a flying wing aircraft where there is no fuselage at all. So, a blended wing body aircraft, as I said, is a blended body or hybrid wing body. It's like it has no clear dividing line. So, the aircraft has distinct wing and body structures that are smoothly blended, and there is no clear dividing line. So, how is it different from a conventional design aircraft? Now, the thing is, flying wing design they are defined as having two separate bodies and only a single wing, though they may be structured protruding from the wing. And blended wing body aircraft have a flattened airfoil-shaped body, and these wings that are blended to the fuselage, they are responsible for most of the lift that is produced in those aircraft, and they compensate for more than 90% of the lift produced in those aircraft. Now, these are, as you can see from this graph, this is a conventional aircraft, and as you can see, the lift profile on the upper surface of this aircraft is maximum on the wings, and on the fuselage it is going less, and whereas the weight profile of the aircraft is maximum at the fuselage. So due to this difference, there is a bending moment that is created in conventional aircraft, and to compensate for this bending moment, we need a structural rigidity, and to build that structural rigidity, that in turn leads to more weight of the aircraft, so that reduces fuel efficiency. And so we implement now researchers are implementing these kind of designs that are blended wing, where you can see the lift profile is like in uniform and maximum at the fuselage, and the weight profile is almost similar to it, and there is no such and the bending moment is reduced significantly, and due to which the overall stability of the aircraft is enhanced profoundly. Now, history of blended wing bodies. So this is not a new concept. This has been proposed 27 years ago, and research is going on and on and on. But still, we are still on a development phase. And the idea, the basic necessity of blended wing body was to accommodate more passengers. So as I said, it is not a new concept. It has been considered by Houghton and Northrop, and in the mid 1930s and mid 1950s. So this is like around more than 100 years old concept. And as you can see, aircraft was previously known as tailless airplanes and flying aircraft. Now, these are two prototypes that were made to demonstrate blended wing bodies. And the first one is a turbojet powered H-229 flying wing aircraft, and this one here is the Northrop 91M aircraft that was designed in 1940. This is just a mock-up of the B-12 bomber that we use at the moment. This is the N9M, that is just a prototype. That's not a full-scale model. This was just a proposed prototype for the aircraft that was to be developed, and this has an 18-meter span, and a takeoff weight is more or less 1600 kilograms. So this is the first tailless flying wing, the D8 aircraft designed by John Doe in 1911, and this is the, as we all know, we are familiar with this, the B-2 straight cell bomber. So now my friend Aslam is going to continue the presentation.
Good afternoon, everyone. I am Aslan Malik. So I will be discussing about the advantages, disadvantages, applications, and the future scope of blended wing body aircraft. So starting with the advantages. The blended wing body can accommodate about up to 800 passengers. The Airbus A380, which holds the record for carrying the maximum number of passengers of a day, but our blended wing body can accommodate more passengers than the Airbus A380. And speaking about the bucket area, the area which is in contact with the external airflow. By the blended body wing configuration, it can decrease the bucket area, which in fact it can decrease the interference drag, which in turn increases the lift to drag ratio. And coming to the engine part, it can reduce the noise generated by the engine, and it uses 25% less fuel compared to the conventional configuration. And coming to safety part, which is an important factor considered while constructing an aeroplane, it has safety measures already taken, and it is it has lower fare compared to the conventional configuration. So speaking about the aerodynamic benefit of blended wing body, the aerodynamic benefit of blended wing body comes from its fuselage and wing design. So the affected area, as already spoken, the area which is in contact with the external airflow, the configuration of blended wing body decreases the lift to drag ratio, which makes it aerodynamically stable. Now the disadvantages of blended wing body. The blended wing body, it has a cylindrical pressure distribution, which in fact increases the bending stress generated by it. Normally the normal aircrafts, they have a cylindrical shape, which requires less pressure and it increases its strength, and it is easy to pressurize compared to the internal shape of the blended wing body. Now coming to the applications, it can accommodate more passengers, it can be used in military applications, and it can be used in military vehicle operations, and due to the stealth UAV, it can be used in defense operations. It has more space, so it can carry more cargo, and it requires a shorter runway compared to the conventional configuration. So speaking about the future scope, with the increasing population exponentially, we cannot have a air traffic jam. So we need an aircraft which can carry more passengers, which can carry more cargo, which supports less pollution, and which has a less runway. With these factors in configuration, we can assume by 2030 we can have an airport in which we have blended wing body with its breath-forming design and a body like a US. That's it from my part. The rest will be.
Good afternoon, everyone. My name is Haidar. I'll be talking about design and structure of a blended wing body aircraft. So first coming to the nomenclature of a blended wing body aircraft, it is similar to that of a conventional body aircraft. The only difference is that the fuselage is called the center body which carries the payload in that, and it has turbofan engines that are pylon mounted. Pylon is nothing but the structure which holds the thing. It is similar to the missile holder in the wing of an aircraft, conventional. So these two look similar, but there are two different types of aircraft. From the exterior point of view, they look similar. So the main difference is that this has a straight leading edge and trailing edge, and it doesn't have any fuselage. All the payload is carried in the structure of the main body structure, main wing structure itself, whereas this has a separate fuselage in this. And in a blended wing body aircraft, the fuselage and the wing is blended so that it appears like a single body from outside. But the problem with that is we can't have a cylindrical fuselage. The fuselage needs to be flattened. Because of that, the strain needed for the same amount of internal pressure will be more when compared to that of conventional aircraft. To compensate for that, Boeing and NASA conducted a study in which they proposed two types of fuselage structure. One is a multi-purpose structure and another one is an integrated screen and shell structure. In a multi-purpose structure, there will be a separate compartments which will have their own inner shell that will resist internal pressure, and there will be a separate outer shell which will resist the bending stresses. But the Boeing was opposed to this idea and proposed that the external shell should be able to take both the bending stress as well as internal pressure if there is any case of leakage of the pressure in that. And they told that there's no need of an internal shell. Both the body and the outer shell should be integrated, and there should be no separation. Because of that, there will be an increase in the weight of the aircraft, but the advantages of the aircraft overcome that of the disadvantages of the aircraft. So this is a project conducted by EU in between 2002 and 2005. VELA stands for Very Efficient Large Aircraft. So it was aimed to develop the skills of designing the large aircraft, and they investigated two extreme configurations of a blended wing body with respect to placement and blending of the wing with the fuselage. So these are the two baseline concepts studied by them. This is VELA 1 and VELA 2. By combining these two baseline concepts, they created a prototype named as VELA 3. This is said to have like a capability of carrying 750 passengers, and it has four engines that are mounted under the wing, and it has like 4 to 10% better lift to drag ratio, and it gives 10 to 10% saving in the maximum takeoff weight. And so this is another study conducted by Cambridge and MIT. So the aim of this project was to design a silent aircraft for passenger purpose, and it began in 2002, and this consists of people of 35. It's considered a team of 35 people. A result of this is SAX-40, this aircraft. This was introduced in September 2006. It has a carrying capability of 215 people, and it has advanced and new noise minimizing aircraft system, and this can cruise at the speed of 0.85 Mach, and this generates a powerful noise of 63 decibel, which is 25 decibel less than that of Boeing 777-200, and this is 25% more fuel efficient than that of Boeing 777-200. So this is the project is known as active flight control for flexible aircraft. This was introduced in 2020. In this aircraft has a capability of carrying 450 people. This has a 2 turbofan engines that are mounted in the tail part, and it has a cruising speed of 0.8. That's it. Now Daniel will be continuing.
Good afternoon, everyone. Good afternoon. I will talk about some Airbus Maverick and Boeing X-50. Before that, these are some blended wing aircraft. Airbus Maverick, which is an experimental UAV, Boeing X-48. This I will talk later. Located at 812. These are especially built for US Army. Now they are using it. Northrop Grumman back. This also used by American Army, especially for CIA. And last one is the Lockheed SR-71 Blackbird. It has okay. Now coming to this point, Boeing X-48. Actually, Boeing and NASA joint developed this in 2001. So the main aim was to study the blended wing aircraft, big blended wing aircraft. Okay, so this first flight was taken on July 20 and 2007. Next. Actually, Boeing and NASA developed three prototypes. That is X-48A, X-48B, and X-48C. This is Boeing X-48A. So this was primarily made up of composite and powered by William J. Powered by three turbojet William J-24, and actually this plan was cancelled because some of the technical issue. So this is a specification. It has a wingspan of 10 10 centimeter. It has weight 1,130 kg, and it can go up to 265 km per hour. Now coming to the specific B. As I said, the X48A was cancelled. So going approaches Canard Aerospace to design and build a smaller UAV. So this prototype was 8.5% scale model of the actual aircraft, and the first flight was taken. The first flight was taken on 2006, and now these are some of the specifications. The weight is 225 for previous one. The weight was 1,130 kg, and it can go up to 220 km per hour, and it can go up to 3,000 meter height. Okay, and it has 3 JetCat T200 turbojet. Now come to the 848C. It is the advanced version of 840X40B, and it had in this prototype they made some upgradation, like they add 2 fins to reduce the noise, and they reduced to 2 engine. But in previous model they were using 3 engine. So now they are using 2 engine. Let's talk about some of its specifications. It has 6.25 meter wing span, and it has weight 225 kg, and it can go up to 220 km per hour, and it can climb up to 3,000 meters. Okay, next. So now this is Airbus Maverick. So its full name is Airbus Maverick. Its full form is Model Aircraft for Validation and Experimentation of Robust Innovation Control. So it is also an experimental UAV made by Airbus in 2019. But they kept secret until 2019. They revealed in 2020 at Singapore Air Show. So these are some of the specifications. It has length 2 meter, and wing span is 3.2 meter, and wing area is 2.25 meter square. So Airbus recently said they are working on Airbus Zero, which will be fully hydrogen powered Airbus, and it will come by 2035. Now this is the video of Airbus Maverick, and now Arnav will conclude. Now this is the video of Airbus Maverick, and now Arnav will conclude.
So I would like to conclude our presentation by stating that the blended wing body aircraft is a revolutionary concept, and we are still developing it. As I said, why do we call it an emerging technology? It's only because it's still under development, it's still emerging. It has hopes to reach the commercial field, the commercial aircraft, the airlines, and basically Wing body aircraft are currently facing a lot of challenges because the tools that are required at the that are required to design these aircraft, they are at the commercial stage. So, like, we are still yet to find the proper tools to design and develop more and more wing bodies. And if in the next decade we do develop these tools, there is a very high chance and a very good probability that we get these wing bodies in the commercial line. So, thank you. I'll end the presentation. Yeah. And these are the references that we used for the entire presentation.